Hi everybody. So we already watched, or you already hopefully learned about velocity and acceleration concepts in the last video, and now we're going to go and do the actual examples. Okay, so these are very important examples. Hopefully they highlight the most important things you need to know, and you can further consolidate your understanding of the topics. So just remember, everything we will be talking about is an object moving in a straight line. So either left to right or up and down. So imagine, a little remote control car just going back and forth along a line, or imagine you holding a baseball and throwing it straight up in the air. Okay. So this example one, the position of an object moving on a line is given by s at t equals 6t squared minus t to the power 3, where t is greater than or equal to 0, okay, where s is in meters and t is in seconds. Determine the velocity and acceleration at t equals 2, so that's at 2 seconds, and interpret their meaning within the context. Now you'll notice as part of this video, if you go down, I have started writing in red the main ideas that you need to understand in order to answer these questions. Okay, just to kind of help so I don't have to write sentences with my trackpad as much. But if you want to take a different color and just kind of go and copy these, basically it's interpreting the word problem in what you need to do in terms of the calculus. So if that helps you, you can copy it down. So velocity at 5. So first we need to find the velocity function, which is just the first derivative of the position function. Okay, so that is just 12t minus 3t squared. Okay, so if we put 2 into that velocity function, we get 12. Okay, and the units are meters per second because it's rate of change, right? The change in y with respect to the change in x. So then we look at acceleration. So remember, acceleration is just the derivative of velocity. So in this case, it would be 12 minus 6t. So acceleration at 2 is just 12 minus 12, so it's 0 meters per second squared. Okay, so what does this mean? Well, velocity means that at 2 seconds, the velocity is 12 meters per second. So therefore, the object is moving at a speed of 12 meters per second in a positive direction. Okay, so it means that's going to the right in this case. And the object is moving at a constant velocity since our acceleration is 0. Okay, that acceleration of 0 means that the velocity is constant throughout the entire time. Okay, so when is the object at rest or changing direction? Well, that would mean that velocity is 0. That is when that happens. So we just set our velocity, 12t minus 3t squared, equal to 0. So we can actually common factor out at 3t here, and you're left with 4 minus t equals 0. Sorry, end the bracket. So our solutions are at t equals 0 and t equals 4 seconds. Okay, so at 0 seconds and at 4 seconds, the object is either at rest or changing direction. In which direction is the object moving at t equals 5? So to answer this question, we just find v at 5. And if the velocity is positive, it's moving to the right. And if the velocity is negative, it's moving to the left. So v at 5 actually ends up being minus 15 meters per second. So therefore, it's moving to the left, since v at 5 is negative. Okay. When is the object moving in a positive direction? So now part C was asking at a specific point, but now it wants to know all the times when velocity is positive. That's when it's moving in a positive direction. So this is also asking when is the slope of the tangent positive. So we take our 12t minus 3t squared. And we want to solve the inequality for when it's greater than 0. Okay, so we can take out here a negative 3t again, and you're left with 4 minus t greater than 0. Okay, so now you can either graph this or you can create a table. Okay, if you create a table, you look at t equals 0 and t equals 4 as your zeros, and you graph before and after. So we don't care about before 0, so we just care about between 0 and 4 seconds, and then after 4 seconds. Okay, so we just do a little table here. So because we know it's changing direction at 0 and at 4, so we just need to look at between 0 and 4 and then after 4. So if we analyze what's going on here between 0 and 4 seconds, well, our velocity, if we put in something between 0 and 4 to this, you get a negative result. And 4 minus t, you will get a positive result. So our velocity here is negative. But if you put into the factored out velocity formula a number greater than 4, this is still negative, but now your second factor is also negative, leading to a positive result. So that means that velocity, the object is moving in a positive direction for all times past 4 seconds. I feel like I did this wrong. Oh, that's right. Okay, I will go back to that or edit that if it's wrong. All right, so when does the object return to its original position? So for example, solve the basically when the position is equal to 0. So this isn't velocity. We have to think about this as position. So we take our 6t squared minus t to the power of 3, and we set it equal to 0. Okay, so we can common factor out a t squared, and we're left with 6 minus t equals 0. So therefore the answer, when t equals 6 seconds, it does go back to the original. Okay, and finally part F, when is the object accelerating in a positive direction? So this is going to be true when our velocity is positive and our acceleration is positive. And I know what I did wrong now. Okay, sorry, go back and fix this. I factored out a negative 3t, so this should have been t minus 4 here in brackets. So this here is a negative, and this is a positive, and this is a positive, and this is a negative. So the object is accelerating between 0 and 4 seconds. That's my problem, because I factored out a negative 3t. I made a mistake, so that means after I factor out a negative 3t, this should be negative 4, and this should be positive t. So then I just rearranged it. Okay, so we go to part F. So our velocity is greater than 0 and our acceleration is greater than 0 is what we're looking for. That's when you know it's accelerating in a positive direction. Okay, so we know that v at t is greater than 0 for times between 0 and 4 seconds. But what about acceleration? Okay, so we take our acceleration function, 12 minus 6t, and we solve for when it's greater than 0. So you get negative 6t greater than negative 12. So t is less than 2. Remember, when you divide by a negative, you have to switch the signs. So therefore, they're both positive between 0 and 2 seconds. So note that this is when they're both positive, so this is when the object is accelerating in a positive direction. Okay, so to kind of help you understand this further, let's go ahead to GeoGebra and look at what's going on, and you can kind of look at the graph in the context of all of these questions. Okay, just a minute. Okay, so we have S at t, oops, sorry guys, S at t equals 6t squared minus t to the power 3. Okay, so how can we analyze this cubic function? What do we kind of look at here? Well, when you guys, I specifically am showing you guys how to do this because I want you to know these skills, okay? So notice that you can't see everything. So you press this little gear and go to settings, and we want to change our Y max to a lot higher, maybe 40. Okay, that gives us a better view. So think about it. It asked when velocity is positive, so when it's moving in a positive direction. So that's anytime the slope of this tangent is positive. So you can see the slope of the tangent is positive between 0 and 4 seconds. That's when the function is increasing, okay? But it's only accelerating between 0 and 2 seconds. That's because the slope of the tangent is only getting steeper and steeper and steeper up until 2 seconds. After 2 seconds, between 2 and 4 seconds, although the slope is positive, the actual value of that slope is decreasing and decreasing and decreasing until it turns around at 4 seconds. So I just wanted to show you kind of what that looked like. Okay, the next example, example 2, I've actually completely written out for you because it's so much writing that I just thought the trackpad would not be doing it any service. So I have it written out for you. So you can choose if you want to pause the video at segments and just copy out the written portion, which would allow you to then just listen to the reasoning and add separate notes as I explain. So here we have, again, an object moving on a horizontal line, and they want us to just analyze all of the motion for the first 12 seconds. So this is a very open-ended type of question that you will run into, and I'm going to show you how to analyze it. So I always start with analyzing the position function, which is S at t. I always want to look at the initial position, so at 0 seconds, and the final position, so in this case, that's 12 seconds. Okay, and I put the units every time to orient my brain to what that actually means. So that means we start at the origin, and we finish 24 meters to the right of the beginning. Okay, now we wanted to check out the velocity. So we find the velocity function, which is just the first derivative of the position function. And you'll see I have it in its unfactored and factored form. Okay, we find the initial velocity. So right at the beginning, the velocity is negative 10 meters per second, which means it's moving to the left initially. And at the end, we're at 14 meters per second, which means it's moving right at that time. Then we want to find out where the object is at rest or changing direction. So we want to solve for when velocity is 0. So in this case, velocity is 0 at 5 seconds. Okay, so I also notice that I find the position of it at 5 seconds. Okay, because that means that's kind of as far as it's gotten in that direction. So that's negative 25 meters or 25 meters to the left of the starting point. So then we look at when it's moving left and when it's moving right. So it's moving left when velocity is negative. So in this case, that's between 0 and 5 seconds. And it's moving right when velocity is positive. So notice that's between 5 and 12 seconds. Okay, notice that I include 12 and I include 0, but I do not include 5 because it is moving neither right nor left when it changes direction. So now I know when it's going to the left, when it's going to the right, and when it turns around, but let's look at when it's accelerating and decelerating. So our acceleration is the first derivative of velocity, or the second derivative of the position function. And in this case, it's just a constant of 2. So that means that velocity is constantly changing at a rate of 2 meters per second every second. Notice I didn't say that it was always increasing, because that's even though it is increasing, it's kind of confusing to use that language because that doesn't always mean accelerating, but it is constantly increasing. That would be correct to say. However, it is not constantly accelerating. Between 0 and 5 seconds, the object is actually decelerating because the velocity is negative there and the acceleration is positive. So imagine we found our original velocity to be minus 10 meters per second. So then if velocity is increasing, that means it's going from negative 10 meters per second to negative 8, to -6. So as velocity increases, the object is actually slowing down. It's getting slower and decelerating until it turns around at 5 seconds. And then it starts to accelerate at a rate of 2 meters per second every second. So 0 meters per second to 2 to 4, etc., all the way until it gets up to 14 at 12 seconds. So I'll just try to hide that. Here is your number line. So you create an S line at the bottom, and that includes all of your positions which you've found. And then you use this to show the direction, the deceleration, where it turns around, and the acceleration. Okay, so our final example involves a quadratic. So a ball is vertically hit upward, and its position function of the ball above the ground is modeled by this quadratic. Okay, so let's take a look at what the graph of this quadratic looks like. Okay, so remember, this has to do with a ball being vertically hit upward. So now I'm going to do a terrible drawing of a little person down here having a ball, and it's just throwing it up, and then it's going to come back down again. Okay, that is actually the picture of what's happening. The ball is just going up and going back down. So when you see this position function, we often think about, oh, they're throwing the ball in this pattern, but that's not what's happening. You can think about this as the distance from the mitt. Okay, so you can think about this as the distance from the mitt. Okay, you can see that we start here at 1 meter, so the mitt is 1 meter above the ground, and then it's caught again at 1 meter above the ground. Okay, so just remember, when you're looking at a quadratic, when it's increasing, that means velocity is positive because the rate of change is positive. The slope of the tangent is positive. But notice, until it reaches its maximum, it's actually decelerating because the slope is going to be getting less and less and less steep. So when you throw it, it's at its fastest until it reaches its top, and then it turns back down. And then on its way down, though, it is accelerating because the slope is getting steeper and steeper and steeper. So determine the maximum height of the ball. So we have quadratic methods of doing this, -b/2a, but now we can use derivatives to find this. So this is actually when the velocity is equal to 0, which is a lot simpler to solve. So velocity is -10t plus 30, which is just a linear function. So now you just solve, -10t plus 30 equals 0, which gives us t equals 3, which is, as you can see, a lot quicker to find than going and doing all of the quadratic problem solving. Okay, so then the maximum height of the ball is s at 3, which is 46 meters. So that's the maximum height of the ball. Determine the velocity of the ball when it is caught. So notice we have to first figure out when it is caught. So we're assuming that that's at 1 meter. So we set our position function equal to 1. Okay, so then you move the 1 over, and then you can factor out minus 5t. Then you're left with t minus 6 equals 0. So it's caught after 6 seconds. So our velocity at 6 seconds is -30 meters per second. So we can say it's at a speed of 30 meters per second in a downward direction. Okay, guys, I know that was a lot to take in. I hope that these concepts are getting more solidified in your mind, and that if you have any questions, you guys will let me know. So thanks for watching. Hope you learned lots.